Hello and welcome. In this video we are going to look at some tools and techniques that we can use to test out our network interfaces to make sure that they work. If you were watching my other video that I recorded recently about how to configure our network interfaces, you'll notice that I finished that video by suggesting we've made a change, but something we haven't done in that video at least was make sure that that change actually works. And this is something my students run into all the time, where they tell me, I followed the steps in that tutorial exactly. Everything is working. And then we sit down and we test it out, and whether it be because of a typo somewhere or an error message that they missed or whatever reason, something's not working. Just because you followed the steps, just because you typed in the commands, doesn't necessarily mean everything's doing what it's supposed to do. You have to test it out and make sure. So what we're going to do in this video is look at several commands that we can use to both gather information about our network and to troubleshoot some of the common problems that you might run into if you were making changes to your network configuration. So this will be useful to you anytime you're working in a network, anytime you're updating your network configuration. So I've got just a short list here, a few commands that we can use to troubleshoot common network problems. And these include things like the ping command that allow us to send out a packet, try to reach another machine, and see if we can get responses from it. This will help us find out if if we can actually connect to our local network, our gateway, things outside our gateway, and that will help us diagnose what's going wrong. The IP command, particularly IP address show, and potentially even IP route show, are going to allow us to confirm our IP address settings to make sure it is set the way we think it is. ARP-N is going to show us our address resolution protocol table, our ARP table. It's just a map of, for the machines on our local network that we know about, this MAC address corresponds to this IP address. So do we know that that machine exists? The SS command, with a list of options there that is actually all in more detail on the next slide, this is going to allow us to look at the local machine that we're currently logged into to determine what ports does it have, sockets does it have available to communicate with other machines. So in the previous video, I had just set up a network interface for a machine. We gave one a DHCP address, we gave one a static address. We should test them out to make sure that they work. So I'm going to bring in the C8 machine that we gave a static address to, and the first thing that I might do is try to ping, using the IP address, another machine in my local network. In this case, the only one I'm absolutely certain of, actually, you know what? If I ping that machine, it's going to mess up my ARP demonstration in a minute. So yeah, the only one that I'm absolutely certain of is the machine that's supposed to be my gateway. So I'll send packets to it and see if I get responses from it. And okay, that's working. I am getting responses. And what this is telling us is I'm sending ICMP packets to this machine. It's listing the order of the packet as they come back in, how long the round trip took between sending it and receiving. And you'll notice, by default, this does not end. It is just going to keep doing this until I eventually interrupt the command with something like, say, Control-C. At the end, it's going to let me know how many packets in total I sent, how many of those came back, if less came back than I sent, that is packet loss. That means somewhere within my network, well, packets were getting lost. They weren't being passed on to where they were supposed to go. In this case, I got 0% packet loss, which is great, and I would be very surprised if I saw anything else, since this is inside a virtual network in this machine. If you start, it's seeing 1 or 2% packet loss, I don't think is that big a deal. You could talk to more network-focused admins, and they might be unhappy about that, but that's semi-reasonable. I know a network that I worked in some time ago, I was experiencing 30 to 50% packet loss, and that made that network pretty much impossible to work in. And it will also let us know the total time the command was running, and it will give us some details about the round trip between our machine and the machine that we were pinging. So the shortest time between sending and receiving the packet back, the longest time between sending and receiving the packet back, the average time that it took, generally that's useful information, and the mean deviation, effectively how varied was this data. We can see a lot are around the 130 to 160 range. And yeah, there's the nice, really long one there. If we don't want to send infinite packets, we do need to include -n and a number of packets. Maybe we send 10, a nice round number. I'm mixing up my commands. That should be C for count, the count of packets that we send. And it will stop after it sends 10 packets and give us similar information. So for each packet, in sequence, did they get received? How long did they take? And then at the end, that overall detail of were any packets lost and what does our round trip time look like. So this lets me know I can reach another machine in my local network if I use its IP address. As I've talked about in other videos, most of our users are not going to be using IP addresses. They are going to be using host names. The human brain just doesn't like long chains of numbers. It is much better at remembering names and meanings and symbols. So I might have to try to look up a machine by name. And in a previous video, we looked at how to set up hostname resolution. So I'm just going to quickly look back at my etc hosts file. Oh, that's right, I don't actually have etc hosts file on C8 demo because I hadn't set that up. So like I described in that other video, in order to use that local hostname resolution, you need to set that on every single machine. So I could vi etc hosts. There's those two loopback addresses that we will not change, and I will set up 192.168.122.1 as gateway, or as gateway.demodomain.ca. And from that point on, I should be able to say ping gateway. And it does some quick DNS lookup for us using that table and says, okay, there's the machine you're talking to. So that lets me know at least local hostname resolution is working. If etc hosts was not working, that would be a huge problem. But is DNS working? Can I actually reach outside my network? Well, I might ping 8.8.8.8. It's a publicly accessible DNS server. If you can connect to the internet, you should be able to reach this DNS server. Don't send a whole lot of packets to it. It is actually a functioning server. A 5 count should let you know if you can actually connect. If you can't ping that, that means there's something wrong with your network. Either this machine doesn't have a gateway to know how to get outside, or that gateway is not willing to pass your traffic on to the outside world. And then you can go and diagnose that. That did work, however. We reached that machine. Of course, it took significantly longer to reach that than it did a machine in my own local virtual network. That's not a surprise. If we want to find out if DNS is working, we could maybe ping a well-known domain name. Again, don't send infinite packets to it, just a simple 5 count or something, just to let us see if this host name gets resolved and gets resolved accurately. And sure enough, it does. That equates to 142.251.41.35. And the packets get sent and they get received. That all looks good so far. If any of this didn't work, I would now need to start diagnosing, well, can I reach my gateway? Is my gateway responding? If I send a packet from my gateway to outside, does the outside world respond? If it doesn't respond, then maybe there's an issue between your gateway and the outside world. If it does, well, if the outside world responds to your gateway, but not your internal machine, like my demo machine here, there's something wrong with your gateway. It's not willing to pass traffic on. Or maybe you didn't tell your internal machine where the gateway is. So maybe you want to go back to your IFCFG file and look for that. Now, I need to set up the host entry for my other machine here. So if I IP address show over here, okay, this machine is at 192.168.122.246. So I could go over here and I can ping that and I can add that into my etc hosts file. Before I do that though, I want to show the address resolution protocol command, or ARP. So ARP-N is not installed on a minimal version of CentOS 8. So we can just look up DNF provides or Yum provides, depending on how old your operating system is, the ARP command. NetTools. Okay, so DNF or Yum install NetTools. Yes, I want to install that package. Yes. And now I can ARP-N and see my address resolution protocol table letting me know I know about the address 192.168.122.1 across my Ethernet connection. That's its MAC address, and I can reach that using my local interface ENP1 as 0. Once I start reaching out to my other machine over here, which we just looked up and saw that it's at 192.168.122.246, before I do that, I'm going to add that into my local hostname resolution, 192.168.122.246, was it? Yes. And I'm going to call that demo.demodomain.ca. And now I can ping demo.demodomain.ca. And we get responses back. That's great. Now that we have reached out and spoken to that machine and it's in our local network, it will show up in our ARP table. We know about it. Here's its MAC address. Here's the IP address that corresponds to it. So this allows us to quickly see, is communication within my local network working? Having done that, I should be able to go over here to demo, and if I ARP-N, it's probably not installed there either. because this machine has already spoken with my C8 demo machine, C8 demo should already exist in its address resolution protocol table. There it is. And of course, we might go over here and go into etc hosts and add an entry for C8 demo. What else are we going to see? Okay, that's the basics of those. The ss command has enough options that we're going to look at that it really needs a slide all on its own. Just like pretty much every other command we look at, I will never cover every option a command has. I'm just going to cover common, useful ones that you need all the time. Once you understand those, you'll be well on your way to being able to add more options to your repertoire on your own without me. So what this command is going to do is allow you to determine what sockets your machine is willing to accept traffic on. That is, there's some sort of service listening ready to accept this connection. If we don't include any options, it's just going to display the sockets that already have established connections. So the ones that are currently communicating. If you add in -A, it's going to display all of the connections, not just the established ones, but the ones that are also ready to accept traffic. You can add in -T and or -U, and that will get you TCP sockets and UDP sockets, respectively. You can use those both at the same time, so you can specifically see both TCP and UDP, well, not traffic, but potential for traffic. If you add in -P, you can see the process ID of the thing that is actually listening on that particular socket or communicating on that particular socket. So perhaps you may want to end that process if you don't want to be listening on that particular socket. And you might also include -N for a numeric display. Instead of it telling you, it's listening on the name of some service or the name of some protocol, with -N, it's going to show you, well, the numbers, the number of that particular port. Instead of a host name, if it knows it, it will make sure it shows you an IP address. So let's see this on a machine. Let me guess, that's not installed either. Oh, it is. So I'm going to resize my terminal a bit to try to make this all show up on one line. I will have to shrink my text to do that. Why is that still double-spaced? There we go. So there's quite a bit more that has established traffic that you might not have been aware of. So it lists effectively the protocol type of what it's using. In this case, it's only listing the established traffic, or the established connections, how much has been received, how much has been sent, the local address and port number. In the case of a star, that means any IP address. In this case, some of these are just files, and the port number that is using, and the remote, which again, in this case, it's all of this is local traffic. There should be one in here, way down at the bottom. TCP, established traffic, connecting to the address 192.168.122.13, the SSH service, and the remote machine is 192.168.122.1, port 43906. If we wanted that SSH to be telling us a port number instead of SSH, we could add in -N. And now it lets us know it's port number 22. And if I scroll back up, I think it was... Oh no, it was not in fact telling me the host name, it was using the IP address. If we wanted to include the processes that represent these particular pieces of traffic. We can add in our -p, and of course that makes the terminal too wide again. Why isn't it showing me the oh, there we are. So some of them are showing me a process number. Not, unfortunately, all of them. There are certain conditions under which they show the process IDs, generally not all of them. If we add in -a, I should be seeing all traffic, not just the currently connected traffic, and I have to shrink my terminal again. I'm not even sure if that's still visible in the video. I'm going to drop off the P because we don't necessarily need that, because that is causing part of this problem. Let's try to squeeze this a little narrower and see if that works. Okay, hopefully that's a bit more visible. So it's now going to show me, because I included -a, sockets that are ready to accept connections, not just the ones that are currently established. So I have a number of sockets here that are open, potentially ready to receive connections, although it looks like, no, this machine is actually just talking to web server somewhere else. That's probably it, just looking to see if there are updates. And it's just waiting for responses. Listen represents, at least for TCP, sockets that are ready to accept incoming traffic. Established means it has accepted that incoming traffic and there is communication ongoing. UDP is either going to be unconnected, that is, it's ready to accept a connection, or if I add in -u, oh, that's just unconnected. I want to say that shows up as established if there is ongoing communication there. I'd have to set up another service that I didn't do in advance to double check that that works. This information from SS, this is going to be really useful because now we can see what are the ways that a person could be communicating with our machine. So we can see that I'm willing to accept SSH connections to any IP address this machine happens to have from any IP address anywhere in the internet. In theory, anybody could SSH to my machine, which is generally a bad idea. Good news is this is inside a virtual network, so I'm not too concerned about that. If I saw this on my actual host machine, I might be a bit more concerned. But that's a whole topic for a whole nother video. So this is going to let us see what are the ways that we could communicate with this machine, and this is going to be really handy when you start configuring a firewall, because now you can see what ports do I potentially need to be worried about. Or if you start up a new service and you're not sure what port it uses, this is one way of finding out. So what we have looked at in this video, it's even longer than the last one, is several useful commands that we can use to gather information about our machine, the network that it's in, and so we can troubleshoot, can this machine actually connect to other machines. So this is going to give you better control of your machine, how it connects to the network, and hopefully help you solve some problems when it has trouble connecting to the network. Thank you, and I'll see you in the next video.